Hello everyone, welcome to UNC Charlotte. Today I'm going to introduce our research on dynamic wireless power transfer for railway applications. This project is supported by US DOT, Federal Railway Administration. Now let's start it. UNC Charlotte is the first in the US to research and demonstrate WPT for railway. Over 80 students benefited from the research in more than 10 years and counting. This is our wireless power transfer system. On the rail side, there are transmitters and controllers. On the locomotive side, there are receivers and controllers. The system can transmit power from the grid to the locomotive. Let's see how it works. The system gets power from the grid. The transmitter generates an electromagnetic field. The energy is transmitted in the electromagnetic field from the transmitter to the receiver. The receiver sends the energy to the locomotive. There is no cable between the transmitter and the receiver. Energy is transmitted through the air. There are two key components. The topology, mainly about the electrical parts, like inverters, rectifiers, and controllers. And the coupler, mainly about the mechanical parts, like the transmitter and receiver. The topology is called dynamic LCLS composition topology. There are 3 transmitters and 1 receiver. All the transmitters are connected in parallel. They use the same gate drive signals and input DC and generate the same magnetic field direction. The receiver can move above the transmitters during charging. There are many advantages, including reduce the passive components, achieve small size control circuits, have a low power loss and a high efficiency, and also it is reliable and robust. Another key component is the coupler. This is our original design. There are transmitter and receiver in the coupler. For the transmitter, there are W-shaped magnetic coils, and for the receiver, there are I-shaped magnetic coils. This is why it is called a WI-shaped coupler. The transmitter and receiver build up the energy transfer channel. The design has many advantages, including the discrete magnetic core design can save up to 93.2% of the magnetic material. The small size and lightweight make it easy to install. The modular design is easy to expand, and it has a relatively high coupling factor and the highest efficiency of 94.7%. We have developed a dynamic WPT system. It includes 3 transmitters with inverters, 1 receiver with a rectifier, a trailer, 2 tracks, and other test device. For the static charging, the output voltage and current get the maximum values at 0 misalignment. Also, the system gets the maximum efficiency at this point. In addition, the system can get high efficiency even if the misalignment is high. Like the misalignment is 16 inches, which is about 1/3 of the receiver length. The efficiency is still over 90%. We also tested the system at various input voltages and load resistors and get the efficiency map. The system can get a high efficiency of over 93% in a huge area. For the dynamic experiments, The output is stable and the total efficiency maintains the highest level when charging in motion. Let's see how the system works in the future. It can charge the train when it is parked or charge while in motion. If you have any questions, please feel free to contact us. Thank you for watching.